Morning guys, today is the day when the big upgrade of the Powerwall will be finished. I got what I need, in particular the new board for the cell voltage monitor arrived, and I have already put all the components on this, so now we have all the nice connectors on there. So this is one part of it. We will start with changing the new controller board, put this into the controller box, connect all the peripherals, and yeah, this should then already work. It just needs to maybe set some parameters a little bit different. Every time the board is changed, there is some unique components to every board, like resistors in voltage dividers and these kind of things. They always need to be then set to the individual board. I have the cell voltage monitor. So for this I have made two wire harnesses for the voltage sensing leads. Of course, similar to a BMS. So yeah, this is two. And then I have made myself the data cable for in between. This will all come into a this kind of junction box, small junction box. It will have a transparent cover because we have a nice shiny LED on that board, so we want to see that. Okay, then you can see here the switching power supply. This is a 12-volt power supply. You know, a few months ago I only have a power supply which is plugged into a wall socket there. It fell out by an unknown reason. This will of course not happen anymore if the power supply is installed properly. I have thermal paste. This is for my 3 temperature sensors. I have just placed those on battery cells before, and this is of course completely useless because the battery cells, they do not emit any heat, so they would just show ambient temperature all the time. But this time we will place those 3 sensors on strategically important places, and I will show it to you where they come. Okay, then I have bus bars. This is for my 12-volt bus there. It will be nice with these ones. I have some other small stuff, and you will all see where this comes. Okay, let's go to the Powerwall and I will show you where something coming. There's one change I already did off camera, and I will explain that to you there. What did I change here? The column meter. Let's have a look. So as you know, maybe already, our column meter works the way that we have a shunt. The shunt is producing, depending on the current flowing over it, a certain voltage drop over it. And so these shunts typically are rated for maximum current is producing around 75 millivolts of voltage, and that voltage is then measured. In my case, I'm using a shunt sensor which is modified actually. This is a small breakout board with a sensor on it which is not rated for voltages for battery systems like we have it here. So these small sensors are rated for voltages. In the case, the sensor inside here was a INA 219. So that one could measure maximum voltages of 24 volts. So it is not usable to watch over the whole pack as it is. But what I was interested in was only the feature that it could measure bidirectional shunt voltage, right? I have put an, as I said, INA 219 sensor inside there, and that sensor worked very well for the charging cycle. It was spot on charging, but at the discharging it was very sensitive to noise which was generated by the inverters. So the reading there was off by almost like 17%, which is a lot, but it could be mathematically removed. So when I added the third charger, the behavior of the sensor changed also during the charging cycle, because you have to now consider one thing. These two older chargers here, these are very good builds, right? They have been a little bit more expensive, and the new one, because it's a lower amperage output charger, they have also tried to reduce on costs for the build. So that charger does not come with some features like a soft start and this kind of thing. So it turned out that now the charging side also got some noise on it, and the sensor also started not showing correctly during charge. So my idea was, okay, let's take a look if we can find something better. So the INA family, there's a lot of sensors. I found breakout boards for the INA 226 sensor, and that sensor is actually also advertised as being put on the low side. Not the maximum voltage on that sensor is still below our system voltage. Its maximum is like 36 volts, so we can only use also for that one the feature of shunt voltage measurement only. So I have put a INA 226 here inside, initially without any filter, and it was showing spot on charging and spot on discharging. But during charging, after maybe 1 hour or so, when the system started to get hot or something, the noise seemed to pick up there as well, and it's starting to actually show not 100% correct during charging, but discharging still perfectly. So what I did, I then also added again a filter. Now we have perfect measurement for charging and also discharging, which is good. So that was off camera. It was already running like that for maybe 2 weeks. So now I can say that is the better sensor, that's the better solution. Okay, let's take a look. We're actually still discharging. It's early morning. We're still around 17% state of charging average. Yesterday the charge was 17.7 kilowatt hours, and until now we have removed about 14.7. Anyways, this will be stopped. Inside there is our old board. We have to replace it by the new one. Here I told you my 12 volt bus will remove these DIY bridges here and replace by some new board ones. This power supply will be removed and replaced by our switching power supply. Then we have our 3 temperature sensors. Actually we have 4. This here is the main temperature and humidity sensor of the controller. But then I have 3 thermistors like this one, and they have been before somewhere on the cells, completely useless. And one will come here at the shunt. This is the hottest place in the system. I am measuring up to 63 degrees Celsius there. Another one will come here. This is the most powerful charger, our 25 amp charger, and I have just temporarily put the sensor here on the casing. We will have a small bracket I made by myself, which will hold down that sensor on this one. And the third one here also, I have put temporary a heat sink on the BMS. The other side of the BMS is here on this steel. So we will put thermal paste underneath this heat sink and the sensor here on the top. Here I can measure up to 53 degrees Celsius. I forgot to tell you the charger temperatures there also. Somewhere around 53 degrees Celsius. Okay, this place here is left over. Here will be the 12 volt switching power supply. Otherwise everything is running perfectly. You may have asked yourself already, how is cell group number 4 doing, because we had a problematic cell in this one. So this string here is absolutely average now. it's not showing any sort of non-normal behavior now. But of course there's always a weakest string inside the system, and so that title has been transferred now to the string 15. So yeah. Okay, and the new board is installed. Let's look quickly inside the controller box what is here. On the down, this is a buck converter converting the high voltage DC from the battery to 9 volts constant. This is supplying our system, so directly from the battery. We have our relay board, 6 relays, and this is now our new version 4 controller. The Arduino Mega Pro board. On the board we have our 16-bit analog to digital converter, the ADS1115. Then on the board here, this is the Modbus module. It gets data here from our smart meter. Here we have our battery bus voltage, then a row of MOSFETs. This is for our LEDs, the indicators on the box, then Wi-Fi, our real-time clock, and then connected, yeah, we have a 12-way switch, 3 LEDs, the encoder switch, OLED display, and the LCD display. And new now here, this one is for our cell voltage monitor, and here connected, this one is the column meter. So that's everything what's here in the controller. The software will follow after I finish all the hardware installation. What did I do in the meantime? I have put now the junction box for my cell voltage monitor, the power supply. Power supply is AC connected to there and DC connected here. You know, my plan was using these bus bars to make this, but there seem to be different sizes of those terminals, and these bus bars are much too long. I had to get a suitable terminal block. The data cable for my cell voltage monitor is already here. Next, what I will do is now put the cell voltage monitor board inside here and then connect all the cell strings to the voltage monitor. Yeah, the system here is of course similar to any BMS. I have one harness with 10 wires, the other one has 7. We are starting with ground and then just going cell by cell. Once this is all wired up, before I enter the multiplexer module, I will then check all the voltages for every midpoint on the voltage divider, so that none of the voltages is above, of course, 5 volts, right? So they should all be then between 3.65, or some steps are a little bit different, maybe 4 volts. Okay, let's do that. I will open one of these bolts on every string and just connect one of the wires. Okay, so this was main ground. The first connection point of measurement. Every measurement is related to this point. Okay, I will continue and then I show you the final result. I have now connected all these measuring wires. Each cell is now connected to the BMS and also to my voltage monitor here. The 2 plugs are inserted. I have measured all the voltages on these pins here, and we have everywhere voltages below 4 volts at the moment. So now I can plug in the multiplexer module there. Let's do that. On the other side I have now my data cable, so this one can also be already plugged in. I will close this with the lid. Then the cell voltage monitor is also installed already. Work on our temperature sensors now. I have here temporarily put a heatsink on the BMS, and it has actually reduced the temperatures by around 3 degrees Celsius, and that can be quite a lot when it's very hot here. But of course I did not put any thermal paste yet, and this is what we are going to do now. I'm only interested in the area where the MOSFETs are, so this is here. Let's put some thermal paste there and press it down there initially. Okay, then here again for my heatsink. And this time I will also fill up the area in between here, so that the temperature sensor is connected via the thermal paste there. Okay, put it inside, and let's take new cable ties. And tighten up everything. And that's it. This BMS will not go anywhere anymore, and it will now give the heat to its environment. Yeah, I have bent myself a small bracket out of sheet metal. There's one screw to be removed, and put it through my bracket, and then I can hold this down. But I will add now also some thermal paste there. So the sensor will be inside here, so I'm filling this up with thermal paste. Okay, let's put it in there. So this here is the second hottest spot in the system, because this is the single most powerful device. At least when it comes to charging. And that's already it. So the sensor is held in place. Perfect. The shunt here, the sensor inside already with a shrink wrap over it. So I have already activated the AC side before. I did not want to waste energy which we have, and already start charging the pack. So I can use my heat gun here now and shrink this. Okay, so this one won't go anywhere also. Perfect. So I can now close this again. I have ordered actually a PCB from the PCB manufacturer for this filter, and then you can, who is interested, use this combination to do the same thing. One more thing I have bought, you see this inverter, the socket for the limiter, external and internal. If you do not use one of them, it stays open like this. So what I bought is this rubber cap here for these GX sockets. So now this one is perfectly covered, and insects cannot go inside and make some damage. Yeah, and the last thing left for today is we have to upload the code for the version 4 controller. It's running now and charging the battery, that's no problem. The board versions are usually compatible. The only thing is what's not working is here now this button for the battery monitor switch over, and this is because now a different digital pin is used internally, but otherwise it just worked well until now. But of course now are coming the new extra features, battery voltage monitor and some indications on the app which will be added. Okay, so I will open again this cover here, and then we're going to connect to the laptop and upload the code for the version 4 controller. Before any upload can start, one last thing has to be done. I have to remove the external watchdog from the controller board, otherwise the watchdog will reset during the upload, which takes much longer than the watchdog will accept. Okay, plug in the cable and upload. I'm of course not expecting that everything will run at the first time, so let's see how well it will do. And yeah, there will be probably some lines of code to change anyway immediately. If everything works out to be well, I can close the lid and then I can show you the display. Unfortunately, it's like I thought, so the first numbers on that screen are completely weird. Yeah, it's kind of difficult to check code here while I'm standing at a wall. So I will take this to my computer and then just see if I can find out what's wrong, and then hopefully upload a working version. Okay, until then I will just pack up everything here. The hardware is done, and yeah, I will then continue recording when I can show you also that the software is working properly. Here we are on the next day. Yeah, I was programming a little bit, coding, and now you can see we have indication. Actually now, as you could see on the screen, we have around 3.33 volts on each cell, which is quite near what it is, but there's still some outliers there. I already saw that during idle conditions the voltages are quite acceptable, but I mean there's still some calibration needs to be done probably. But during charging, discharging, I didn't see yet. The voltage differences are getting a little bit bigger, so yeah. I mean, hardware, technically this system is working as it is supposed to do. So the multiplexer is switching from one channel to the other. That works pretty nice, but the measurement is not yet there where it should be. So maybe there could be some optimizations. Maybe I have to put some capacitor somewhere to filter out a little bit noise. Yeah, this is ongoing, of course. Testing will continue, but yeah, the feature is now inside the controller, and we will see what we can do. So here we have some stats. Okay, so this is finishing all the upgrade on the Powerwall, and I ordered a different terminal here so that I can use my other bus bars here. But that will be it, and everything should be done then. So the Powerwall upgrade is done. It turned out to be really nice, for me at least. You know, everything here is very DIY, and also some components also very experimental. And they are made the way that it suits to our case here, that it suits to my interests, and it is not necessarily suiting everybody's taste anyway, of course. But these sort of projects are a great experience, learning experience, and yeah, what shall I say more? The first numbers are already kind of coming in and they're looking very good. So this might be another video, maybe once I have the data set of a whole month, and we can take a look what this actually really brings. Does it save money? Does it recoup? How much energy does it recoup, etc. So this was the first big upgrade of this Powerwall. Maybe one day another one will follow. There's a lot of space this way, but of course that is always the question of money, and at the moment it's still not looking any way promising. Here in Thailand the government is always shutting down borders and then this and that, and it will probably take another year until again guests can arrive here at the property from foreign countries, and then maybe that time we can then again do something. Please feel free, comment under this video. What did you like most? What would you like to see more? But I hope that also something was here for you, what you could maybe take out of this for your own projects at home. Thank you very much for watching the whole video series, watching this video. Please, as I said, comment, subscribe to the channel and like the video, and I see you next time.